So as I mentioned, this is co-authored with my very frequent co-author and colleague, Violca Sidiri, and with a recently former grad student, Susan Tang. When you're talking about payoff equivalent games, it means that they payoff equivalent, they have the same feasible sets of payoffs for all the players. And one type is a provision game with positive externalities, also called a positively framed public good game, and an appropriation game with negative externalities, also called negatively framed public good game, also called by some people common pool game. There's some dispute in a part of the literature about the use of the term common pool game, so we'll avoid it because we don't have a dog in that fight. So I'm talking about games where the MPCR is between 1/n and 1, where n is the number of players. Therefore, there exists a social dilemma in the game. The provision game, in its baseline form, we have each of n agents has an endowment E in her private account, and each can contribute to the public account, where the MPCR is gamma. In other words, in its simplest form, this is a plain vanilla VCM. The paired game, the appropriation game, the group of n agents has endowment gamma NE in the public account, and each can extract from the public account. There's a large literature on these games. It's started, at least famously, by a paper by Jim Andreoni, published 25 years ago now. But there's a very large literature in this area. And they find that subjects allocate more to the public account in the provision game than in the payoff equivalent appropriation game. Now, this literature has not really focused on the full implications of this robust result. And they're quite strong for theory, since the data are inconsistent with the most general form of rational choice theory, as in the work of Sen, A.K. Sen. And therefore, of course, also inconsistent with the special cases of rational choice theory. Standard preference theory, as in the classic works of Hicks, Samuelson, and DeBrew, and as taught in textbooks. And revealed preference theory, or the generalized axiom of revealed preference, or GARP, as in the classic works by Afriat, Varian, and in textbooks. They're also, therefore, necessarily inconsistent with consequentialist social preferences models, as in Fair-Schmidt, Bolton-Oakenfeld's inequality version, in one of my own models with Violca Sidiri. So in this paper, we extend rational choice theory to incorporate moral reference points. We show that this moral monotonicity theory is consistent with existing data. It has novel testable implications. We report a new experiment, and we use existing data and the new data to do extensive testing of rational choice theory versus moral monotonicity theory. That's to say, pre-existing rational choice theory or standard rational choice theory versus moral monotonicity theory. So we include a general class of games that we call GE games with endowments of tokens. We call them endowments of tokens because of the multiplier, and it becomes hard to talk about a dollar here and a dollar there, and a dollar has different values. So it's convenient to talk about tokens. The GE games, where n, the number of players, times GE is in some interval 0 to NW, W in the public account, and where W minus GE is the endowment in the private account of each of n agents. So now the initial per capita endowment GE in the public account identifies the game. So GE equals 0 is simply the classic provision game or plain vanilla voluntary contributions public good game. GE equals W is an appropriation game, or by some definitions, a common pool game. GE in 0W, the open interval, is a mixed game where individuals can either contribute to the public account or extract from it. Now, we elicit in provision appropriation games responses in 3 different mixed games that span the design space between the pure provision and appropriation games. A departure from all previous literature is that we include endogenous contractions of feasible sets, which are non-binding minimum contributions and maximum extractions. This endogeneity of the contraction turns out to be critical for stress testing the theory. The contractions are motivated by Sen's classic property alpha. It provides a direct test of contraction consistency, which is the heart of rational choice theory. And we study empirical validity of conventional rational choice theory versus moral monotonicity theory. Here are Sen's classic properties from his 1971 and 86 papers. There are 2 properties, alpha and beta. You might prefer the term axioms, but we'll use Sen's term properties, which are for all feasible sets where T is a subset of S, and the choice sets T star from T and S star from S. Property alpha is that if X is in the choice set of S and also in the feasible set T, in other words, it's in their intersection, that implies that X is in the choice set of T. Property beta is that for all X and Y in the choice set of T, which is T star, X in the choice set of S, if and only if Y is in the choice set of S also. Again, in words, property alpha states any allocation X in the choice set of S is also in the choice set of any subset T of S that contains X. Property beta states non-empty intersection of choice sets T star and S star implies all elements of T star are elements of S star. I might say, well, okay, that's well and good, so what? Well, properties alpha and beta actually characterize rational choice for finite sets, which is, of course, would be any actual experiment or any actual choice in a real economy, which are finite sets, because there's actually in the real economy no such thing as a continuum of variables, even though in much theorizing we find that fiction convenient. So properties alpha and beta characterize rational choice theory. That is to say, they are equivalent to existence of a complete and transitive ordering of choices. Another simple way, when you're talking about rational choice in the most general frame, what you mean is properties alpha and beta. Okay, we extend rational choice theory to include moral reference points. The definition of moral reference point incorporates 2 intuitions into theory of choice. That my moral constraints on interacting with you in the game we are playing may depend on my endowed or initial payoff in the game. In other words, what belongs to me before I start playing the game with you. And that they also depend on the payoff each of us can receive when the other's payoff is maximized, or minimal expectations payoffs. Okay, why are these 2 strong intuitions? Well, you know, what belongs to me before I start to interact with you, why that should affect my ethical constraints is clear, because it belongs to me before I consider playing with you. The second intuition may be a little less obvious, but it actually, if we think about it, isn't. Because what is fairness towards you. If I'm playing a game with you, what does it mean for me to be selfish or fair? There's no answer to that question unless we know the outlines of the game we're playing. So for example, let's take the simplest possible game. Suppose we're talking about a dictator game. And I think, well, how do I feel about giving you $10? Well, if $10 is the absolute minimum amount that I could possibly give you, then I'm really being a cheapskate and selfish if I choose 10. On the other hand, if the minimum I could give you is 0, and the maximum I can give you is 10, and I give you 10, then I'm being incredibly generous towards you. In other words, we don't really know what fairness means unless we know what the outlines of the games are, in particular, what the minimal expectations payoffs are to the players in that game. So both of these, once we think of them in that way, are clear intuitions. Okay, we bring those intuitions in a very formal way into rational choice theory. So let's look at this in the context of a GE game. And let's consider the simplest case where we have two players. MPCR is before is gamma. Yeah, each player starts with W minus GE in her private account. Each player starts with a claim of gamma 2 times GE from the public account. Hence, the initial endowed payoff of each player, omega E, is W minus GE, the endowment in the private account, plus gamma 2E, this player's claim on the endowment in the public account. And now let's consider some C greater than or equal to 0, which is the minimum required allocation to the public account for each player. So notice we're defining a whole class of additional games once we allow C to be different, anything different than 0, which is what it is in most of the literature. Okay, now let's talk about minimal expectations. Let player 2's allocation to the public account be some G sub 2 greater than or equal to C. The maximum payoff for player 2 as a consequence of player 1's choice is when player 1 allocates W, everything to the public account. In that case, player 1's payoff is gamma W plus G2. The maximum payoff of player 1 is when she allocates the minimum required amount C to the public account. In that case, player 2's payoff is W minus G2 plus gamma G2 plus C. In other words, these are how to incorporate into the simplest case of the provision and appropriation games, the minimal expectations payoffs, where in a Nash response way, they are dependent on the conjectured choice G sub 2 of the other player. Now, there are two dimensions of player 1's moral reference point. Remember, there are two intuitions. That fairness depends on what belongs to me before we start to play, and the minimal amounts that can be allocated to you and me within the structure of the game we're playing. So the two dimensions of player 1's moral reference point, R sub 1 and R sub 2, are the dimensions that player 1 applies to player 2. And if we look at R sub 1, we see that we have a 0.5 convex combination of the endowed payoff omega E and the first player's dimension of minimal expectations. In other words, we're taking the case where those two intuitions about what belongs to me before we play the game and the minimum assignment to you and to me in the game, we're taking the 0.5 combination of those two new elements that we're bringing into the theory. These provide the entries in the left column of the table we're going to look at. The entries in the right column are simply derived from symmetry of the game. So here's what the minimal expectations payoffs and the moral reference points look like in any two-player GE game. And remember, GE games are the whole general class of games we're looking at. And what I want you to focus on in the table, I realize there may be a lot there, but here's what I want you to focus on. That unlike a lot of, after all, our theory is a reference point theory, it's a moral reference point theory. One can get into situations in behavioral economics where the reference points are purely subjective. And so when they're purely subjective, then you run into danger of constructing a theoretical model that is in fact not actually testable in the scientific sense. In other words, you have the possible feature that researcher can observe the data and then go back and interpret the model and always find some way of interpreting the reference point theory. So in fact, the data end up being consistent with the predictions of that theory. So if you look at this table, you see that everything in it is observable, which is a critical point. So our theory is in fact testable. Once we define it, we've tied ourselves to the mast, and anyone else who wants to come along and construct an experiment to test it, they will know whether their data is consistent with our theoretical model or not. We can't, after the fact, dress it up. So you see that everything in this table, gamma, W, C, omega, these are all things that the experimenter defines when he or she parameterizes the experiment. The only exception to that is G sub 1 and G sub 2, but they are observable in an experiment in either of two ways. If you run a multi-period experiment, then G1 and G2, the beliefs about the other player, can be constructed in a Nash-Cournot way by setting that equal to the choice of the other player in the previous period, or you can elicit them directly in the experiment. Okay. The moral monotonicity theory is based on two types of properties. First of all, the R consistency properties. And this is simply the assumption that Sen's properties hold for any two sets that have the same moral reference point. The new properties then are properties MA sub R and MB sub R. MA sub R states that if some player K, who may or may not be distinct from the chooser, the decision maker I, is favored by the moral reference point, then player I's choice set becomes more favorable to player K. In other words, that I's choices respond monotonically to the moral reference point, hence the name of the theory. Property MBR states that if the moral reference point becomes equally more favorable to all players, then player I's choice set favors herself. In other words, there's a little bit of residual selfishness here. These properties, of course, are defined with full set theoretic terminology in the paper, but I don't begin to have enough time in this short seminar to take you through all the formal. They are of course, in the paper. If we have time at the end, I'll show you the formal definitions. Testable implications. Well, with conventional theory, conventional rational choice theory, the Nash equilibrium allocations to the public account are the same for the provision game, all the mixed games, and the appropriation game. And they're not affected by non-binding floors or quotas. In contrast, strong contrast with moral monotonicity theory, Nash equilibrium allocations to the public account are higher in the provision game than in the mixed game, which are higher again than in the appropriation game. They're increasing with non-binding floors in the provision game and the mixed game. and they're decreasing with non-binding quotas in the appropriation game and mixed game. So the testable implications of the theory, and of course what we do is in the tests, we take the predictions from conventional theory as null hypotheses, and the alternative one-sided hypotheses come from moral monotonicity theory. Okay, if we look at data from the previous experiments on the classic experiment by Andreoni and a later really nicely designed experiment by Kajafi and Langa, and we look at the empirical application to their data, we see that, well, the coefficients for others allocation in the previous period is strongly positive. Well, we would hope so, or any Nash equilibrium is not well specified. The GE term, in other words, the parameter that defines when it's 0, it's a provision game. When it's the maximum possible, it's an appropriation game. When it's between, it's a mixed game. That coefficient estimate is for all the parts of the data is negative, as is predicted by moral monotonicity theory. Standard theory would predict that that coefficient is 0. If we look at the contraction term C, Andreoni's experiment didn't involve contractions. Kajafi and Lange experiment did. That coefficient is strongly positive, as is predicted by our moral monotonicity theory. But there are limitations of the data coming from the Andreoni and Kajafi and Lange experiments. After all, their experiments were not designed to test our new theory, and so one might expect that there would be some limitations in that sense. Andreoni's experiment didn't involve contractions, so that whole important test of the theory can't be done with this data. Contractions in the Kajafi and Lange experiment are exogenous, which means they can be binding for some subjects, in which case, if they're binding, then it would force consistency with the predictions of our theory coming from a constraint rather than from behavior. So we run a new experiment with endogenous contractions that are implemented to be non-binding. Our design crosses non-binding contractions with two types of externalities, positive only for our provision game, negative only for an appropriation game, both positive and negative for a mixed game. We observe play in a game and elicit subjects' beliefs about play by the other player. Correct guesses were paid $2, incorrect guesses were not paid. Observed play and elicited beliefs are used to inform non-binding contractions of feasible sets. Here's what our design and the treatments look like. There's a lot going on there. And once again, in the interest of time, since this, I'm just going to jump over this slide. And I'll come back to it if anyone asks later. In new experiment, the best response allocation to the public account, well, in this case, we have guessed others allocation. That's strongly positive, good thing, or it wouldn't make a lot of sense to talk about Nash equilibrium. The GE parameter that defines the game form, whether it's provision, mixed, or appropriation, is negative, as is predicted by moral monotonicity theory. And standard theory predicts that the coefficient on GE is 0. The contraction term C, again, now remember, these are non-binding contractions by design. Standard theory predicts that that coefficient on C should be 0. Moral monotonicity theory predicts that it be positive, and indeed the estimates support that. Now, up to now, and our theory is we're working at the most general version of rational choice theory by Sen, and then adding moral monotonicity to it. And we are not working with versions of theory that economists are most used to working with. So what do I mean by that? Well, very few economists work with, in doing applied work, with Sen's principles alpha and beta. In fact, maybe a lot of economists really have never encountered them. What we usually work with are much, much stronger versions of rational choice theory, as in, for example, neoclassical choice theory as taught in PhD textbooks, has typically a set of axioms that is made sufficiently strong that the preference ordering can be represented by a utility function, and perhaps even stronger utility function that in the end is like twice continuously differentiable. Well, getting all that representation requires introduction of a lot of some very, very strong properties that go way beyond the implications of rational choice, but suit our convenience, especially in applied work and in many theoretical derivations, where it's just a lot easier to work with a utility function. And so we thought, since we found in presenting this work, actually in this paper and in a previous one where we modeled reciprocity in an axiomatic way, that people who were interested in the theory were frustrated, and because we didn't give a utility function. And so we said, okay, we'll strengthen this model enough so that we can represent it with a utility function. Here it is. So keep in mind that we're adding a lot of additional regularity assumptions so as to imply the existence of a utility function. But here's the representation, and it's interesting because it looks very different than what reference point models look like that people are used to. For example, coming out of the work of Kahneman and Tversky. So here we have a utility function. It's for n vectors of monetary payoffs, pi, and given the moral reference point r. So the utility function is a sum of weights w sub k, where k is an individual player, utility of the payoffs, and notice that the reference point r enters only the weights, whereas reference point models that people, if you use reference point models that you're used to working with, for example, coming out of Kahneman and Tversky's work, you would have pi minus a reference point, so that the utility function would look like, well, you know, of a utility function looks like that. It's part of standard PhD. It's Stone-Gary, which is a reference point model, right, of Cobb-Douglas. So our theoretical model looks quite different. Now, if we look at a form that is friendly enough to do parameter estimation, we use pretty standard forms. We use exponential forms, but for both the utility of payoffs and the weights. And that implies a Nash best response function that looks like this. Now, if we apply that to the data from all the experiments, what we find is that the critical estimate of lambda 1, the specification of the utility function is, this is the small selfish part of it, that lambda 1 with the decision maker is greater than 1, it's equal to 1 for all the other players, but that this is a function it's multiplying the moral reference point. What do we find when we use data from the seminal experiment starting the literature? A nice experiment involving contractions, not necessarily known to be non-binding by Kajafi and Langa. And our experiment that we get, the restriction of the theory is that lambda is larger than 1 for moral monotonicity theory. And we find out that all the 95% confidence intervals on this row, they all are above 1. So we can use a more standard utility function approach to applying our model, which makes it easier for others to apply if they want to do so. Okay, if we look now at summary results, summarized at the highest level, the provision game elicits higher average allocation to the public account than the appropriation game, and the appropriation game elicits more free riding, defined as public account allocations of 0 in the provision game or 1 in the appropriation game. I'm sorry, the reverse for the two game forms. Allocation to the public account in mixed games decreases as the initial endowment of the public account increases, controlling for belief about others' allocation. Non-binding lower bounds on public account allocations induce higher average allocations to the public account in the provision game, controlling for the belief of others' allocations. All these results are inconsistent with conventional rational choice theory, but consistent with moral monotonicity. So since I guess we're going to switch to questions in a little while, that shows that I have a little more time to look. This is where I could end. I have a little more time to consider both the literature and, if time permits, some of the more formal properties of the new model. So this literature, it involves two questions historically that go back decades. And they're actually both involved in our theoretical work and our experiment. One is the literature on what's called crowding out, which are the effects on voluntary contributions of imposed minimum contributions to a public good. Now, conventional theory implies 1-for-1 crowding out. And of course, testing for crowding out is exactly what we're doing with this C parameter in the experimental design. Now, going back decades, incomplete crowding out is usually observed. And going back decades, people were discussing, well, what can we do about this result? And how can we bring this into theory? Now, incomplete crowding out is usually observed. And of course, it's consistent with moral monotonicity theory. It's also consistent with Andreoni's warm glow model, as he demonstrated in a 1990 paper, and as some other people in later literature found when they tried to apply the warm glow model. If we look at public account allocations, conventional theory, as I've emphasized, predicts allocations are the same in provision and appropriation games. Larger allocation in the provision game is widely reported. I mean, there's scores and scores of papers that have reported that. That, as I've emphasized, is consistent with moral monotonicity theory. And you might say, well, okay, well, what about some other reference point theory? Well, let's look at the most famous people in this area, Tversky and Kahneman. Tversky and Kahneman's theoretical approach, its reference-dependent theory, it makes the opposite prediction than is found in the literature. And then a surprising result, because I expected to be possibly asked, well, what about Andreoni's model? After all, in that famous 1995 paper, he talks about warm glow and cold prickle. And I always thought, well, you know, he must have developed a theory, since he developed warm glow theory in the 1990 paper and in some later work. And in the 95 paper, he talks about warm glow and cold prickle, warm glow for the provision game, cold prickle for the appropriation game. And I said to my co-author, Riolta, I said, we need to go look at his model and apply it to our data. It turns out that there isn't a theoretical model there. So we thought there would be, there wasn't. And so we decided not to try and invent a warm glow, cold prickle model as an alternative, since it wasn't in the literature, and someone might later say, well, we just didn't do it fairly. Here's the formal statement of propositions, but I want to look, since there's a little bit of time left, the formal axiomatic statements in our moral monotonicity theory that I just did with words in the paper. Well, this isn't any different. These are simply sens properties alpha and beta. They're simply stated for two when T and S have the same moral reference point. So then the question is, well, what are these new axioms or properties? Okay, well, here they are. We have a set of players, big N, they're little n players, and we look at the differences in the moral reference dimensions in set T and set R, and we look at the case where they are equal to some delta greater than or equal to 0, and we have I denote the decision maker's own coordinate, and what we define is a partial ordering of the sets X and Y on the real line, and it's defined as follows: X, let's call it diamond R, if and only if the inf in X is greater than or equal to the inf of Y and the sup of X greater than or equal. Okay, make it easy. Let's suppose that all these sets are closed. Then this is the minimum and the sup is the maximum. Then what these properties are assuming is that the choice set in the choice amount in T for agent K is right shifted from the choice set in S if the set K of these agents are all agents, and that it favors I, the decision maker, only if the set K is a set of all agents. So what we're assuming here is that remember we have theory in a very general form. So this is the way that we bring moral monotonicity into axiomatic choice theory in a formal way by introducing these orderings that are essentially right shifts of the support of the distribution of payoffs. Now, if we look at special cases of the theory, so that the choice sets are singletons, and of course, with very strong special cases, as in standard theory of the firm, theory of the consumer, we have strict convexity properties built in so that the choice sets are always singletons. There's a unique choice. And in that case, if we impose that sort of special case on this, then this right shift of the support, that simply means that we have an individual element predicted to be the singleton in this choice set. It is greater than the individual element predicted to be in the choice set for S, and similarly here. So we see that if we look at this as a special case where the choice sets are singletons, this boils down to the assumption in a straightforward way that the singleton chosen amounts monotonically respond to the moral reference points. And it's as simple as that. It only becomes in a way that looks much more complicated, given that we're wanting to deal with theory at its most general level, including where choice sets are not necessarily singletons. Of course, once we get to a utility function representation, then the choice sets are indeed singletons. Okay, let me stop here so we can go to questions. I think we're just about right on time.
Yeah, Jim, thank you. It's perfect, right on time. So this is Mark Masters. I'm down at Albany State University and Outreach Director for CBEAR. So thanks to many of you who have been using the chat for clarification throughout Jim's presentation. I think we've addressed most of those, but we do have a few questions that wanted to pose in our remaining time. The first one, just generally, Jim, were all of these conducted in the lab or any of them online? Student subjects, were they single day, multi-day? Just speak a little more about the experiment.
Our experiments were all conducted in the lab. They were single day experiments and I'm pretty sure Andreoni's were too. I think Kajafi and Lange experiment may have been conducted online, but I'm not sure about that. Ours were all in the lab.
Okay. And we had another question. Speaking to your rule for eliciting your subject's belief about others' contribution, how was that addressed?
We asked them to state their belief about what the others would contribute, and we incentivized that so that correct guesses were rewarded, incorrect guesses were not. So we directly elicited the beliefs. But I would hasten to add that the data we're looking at from the 3 experiments, right? The other 2 experiments by Andreoni and Kajafi and Lange didn't elicit beliefs, and so we use as beliefs the data from the previous period, as we would, the standard thing one does in sort of Nash-Cornot type models. And we can do the same thing with our data. So we can either use the elicited beliefs as stated, or we can use what the people did in the previous period.
Thanks, Jim. I guess shifting gears a little bit, thinking about policy implications. This was posted in the chat. What are the policy levers highlighted by this work that are not necessarily highlighted by alternative theories?
Okay, well, a clear one would be coming from the contraction of the game. So and this would apply to charitable contributions. It could apply to quotas introduced into common pools. A very strong implication that has some policy relevance would be we're finding from our theory that the introduction of non-binding floors or quotas changes behavior. In other words, if you want to increase contributions to a public good, our model and our data supporting it suggests you can do this by introducing a floor on contributions that is not binding, or that if you want to affect harvesting from extraction from a common account, common pool by some people's terminology, you can do this by putting in place a quota that is not binding. That actually has a quite strong policy implication.
Mm-hmm. We've got a couple of questions coming in. Laura, I think one of our CBEAR colleagues, Paul Feldman, had a couple of questions. I was trying to synthesize several at a time. If you don't mind, unmute Paul real quick while I grab these others.
Sounds good. Paul, I think you can unmute yourself, or I can request.
Yeah, I can unmute myself. Hi, Jim. So I had a question about the representation. It seems to me from the paper that it's not a unique representation. You only, the utility function that you propose is consistent with the axioms, but it's not the only utility function that is consistent with the axioms.
That is correct.
So my question is, what's missing in order for you to derive a unique representation, or why did you not want to go down that route?
Well, I mean, we could specialize we could impose even stronger restrictions on the theory to get a unique representation, but I'm not quite sure why we would want to do that. So let me convert that into a question about standard theory. If you think, for example, about the case that we're most all familiar with, which is textbook preference theory, as in the theory of consumer demand, what we get is a representation theorem that gives us the existence of a utility function and some of its properties. But we ordinarily wouldn't consider it to be a virtue to restrict that theory to say only include CES class of utility functions. If you're going to apply it in empirical work, you might find it convenient for purposes of estimation to assume the utility function as CES, say, but you wouldn't want to restrict the theory to only include that.
So let me ask you a follow-up to that, which is, can you actually say what types of functions would be within the set?
Oh, well, yeah, they would all have to be monotonic in the moral reference points. And you would necessarily want them to be monotonic in the agent's own payoff. They wouldn't necessarily have to be monotonic in other agents' payoffs. So you could have this, yeah, but to be consistent with our theory, the utility function, if you look at these weights, the weights would have to be monotonic in the moral reference point, or it would be inconsistent with the underlying theory. And this function here of the payoffs, you would only want it to be monotonic in the agent's own payoff. It wouldn't have to be in the other agent's payoffs, but you would ordinarily want to allow it to be, because in empirical work in fairness games, you wouldn't want to start from the beginning with a function that was completely selfish in terms of payoffs, because that you almost immediately reject that with the data for some of the subjects in almost any fairness game. But yeah, the only thing you necessarily have to have is that these weights are monotonically increasing in R. Otherwise, it's some other theory.
All right. Thanks, Jim and Paul, for your question and follow-up. We've got time for one, maybe two more. We had a question, what's the rationale for computing the moral reference point as the simple average of the endowment and the minimal expectations payoff?
Okay. Well, let me answer that in a couple of parts. I suppose, I mean, we could have used some other function other than a convex combination, but there's no particular reason for doing that, and it would introduce a lot of, it could introduce a lot of strange properties to applying the theory if the function was strange in some sense. But if I specialize the question somewhat, why weights equal to 1/2? Why not some other weights? The answer is the weights we could use some other weights. In fact, a lot of applications of this theory, we've actually applied this theory to other games, lots of other games other than the common appropriation and provision games. In a lot of applications, you can have any weight theta that's on the open 0-1 interval, so that the moral reference point actually depends both on endowments and on minimal expectations payoffs. What we wanted to avoid is having a free parameter. In other words, theta can be any old value between 0 and 1, because once we introduce a free parameter that can be fit to data after the fact, then we run the danger that our model could be like lots of other behavioral economics models. We could be playing the game where after the data is elicited, then we find parameter values that have our theory survive the data. And so selecting 1/2, it seemed to be an attractive choice, and it's part of us tying ourselves to the mast to make sure that our theory is testable by other people, that we can't somehow get it to fit the data after the fact. But say, well, if you just use a different theta, then we find that our data is consistent after all.
And Jim, one more quickly here. What about risk and uncertainty preferences? Are those incorporated? And if not, why? And could these improve model predictions?
Risk and uncertainty preferences with moral monotonicity. I'm going to punt that question because we haven't thought enough about it enough, and so I don't want to. The honest answer is we haven't really thought about taking it in that direction yet. So rather than just speculating on it, I think I'll just punt on that one.
Okay, that's fair enough. Well, and to that point, we've captured all the questions in the chat. I do apologize if I missed one or didn't get to yours. We've got them all. I'm sure Jim wouldn't mind circling back and answering some. We'll be sure to get those back. This will be posted on our CBEAR website, and we'll remind you, as Laura did, of the next seminar, which will be on February 15th. So please plan to join us for that. And if there's nothing else from any of our CBEAR folks, we will wish you all a very good afternoon, and thank you for being here.